Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for solving systems of quadratic equations. And this section of notes is not in your book, so all of the notes will be here or in class, and then the homework will be a worksheet as well. And the worksheet can be given to you in class, or you can find it on the class website. Now what we're going to do today is we're going to graph a system of equations, but one of the equations is going to be a quadratic. So it's going to be a parabola like we've been doing in the previous two lessons. And then the other equation is going to be a line. And then we're going to find the solutions. And that's basically where the parabola and the line cross. So let's just review how we solve a system of equations by graphing. Now, when we were graphing just two lines on the same graph to see where they would cross, we had to make sure that both equations were solved for y first. And we'll have to do that again, even for the parabolas. We want to make sure that they're solved for y. So this first equation is already solved for y, so that's okay. And this second equation, I'm going to have to solve it for y. So I'm going to have to add the x over. So then I'll have 2y equals x plus 6. Remember, we like the x term to come first. And then I have to divide everything by 2. Now remember, there's a little invisible 1 in front of the x there. So this will be y equals 1/2 x plus 3. Now when I graph this, I'll graph this line first since we just solved it. Remember, we're going to start at our intercept, which is the 3. That's our y-intercept. And then the other number, the 1/2, remember that's our slope, or m. So I'm going to start at 3 on the y-axis, and then I'm going to go up 1 and over 2. And I don't know where the other line is going to go, so I'm going to graph as many points as I can. I can even backtrack or go in the opposite direction, so I'm going to go down 1 and back 2. Okay, so there's my line. And then the other line, let's do in red. So again, I'm going to start at 2, and then my slope is going to be 1. So if I start at 2, and then I go up 1 and over 1, right there is where the lines are going to cross. Okay, and I don't need to make as many points this time because I can already see where the lines are going to cross. Okay. And if I read off that ordered pair, I would go over 2 and up 1, 2, 3, 4. So right there is where they cross at 2, 4. So when we did those before, we emphasized that the ordered pair where the lines cross is your solution. So you have to make sure you write down that ordered pair. And today we're going to do that, except we have a system of quadratic equations. And these systems, like I said, are going to have one parabola and one line. So sometimes the parabola and the line will touch twice. Sometimes they'll touch once. Sometimes they might not touch at all. Okay, so just like when we had our lines, we could have lines that touched once, or they could touch everywhere, or they could touch not at all if they were parallel. Okay, so let's take a look at how these systems of equations are going to look. Now this one, for example 1, is pretty straightforward because they're both solved for y already, so that's good. So I have y equals negative x squared plus 3, and then y equals x minus 3. So the very first thing you want to do for these is identify which equation is the parabola and which equation is the line. And that's really easy to do because the parabola is always going to have the x squared. So this first equation is going to be my parabola because it has the x squared. This second equation is going to be the line. Okay, so this is good review of graphing parabolas that we've been doing. So if you want to, if you want to rewrite it so that it has all the terms, we would have negative 1x squared plus 0x plus 3. So then the negative 1 is A, the 0 is the B, the 3 is the C. And then we have to do the negative B over 2A so we can find our axis of symmetry. So that's 0 over 2 times negative 1. Well, that's just going to be 0. Okay, so when I make my table of values, I know that I'll start with a 0, and then I'll pick a few values above it and a few values below it. You can pick 2, you can pick 3. Sometimes when we're doing systems of equations, it's better to do more points. So you could do 3 above and 3 below your vertex. That would be to your advantage. And then we have to take each of these values for x and substitute it into the equation here. So if I had the 3, I would take 3 and square it, so that's 9, and then make it negative, so that's negative 9, and then add the 3 would be negative 6. So when you do all those substitutions, these are the values that you get. Remember, if you have a nice vertex, a nice ordered pair, here we have 0, 3 for our vertex, then you should get that pattern that repeats in your y column. So really we would only have to do 4 substitutions because then the 2 and the negative 1 and the 6 repeat. Okay, so let me graph the parabola then. We've got negative 3, negative 6, okay, and then we have negative 2, negative 1, and then negative 1, 2, 0, 3, 1, 2, 2, negative 1, and 3, negative 6. So there's where my parabola is going to go. Now we can just connect it with a solid line. We don't have to do a dashed line. We don't have to shade. Now my other line, let me do that in red. This was just my straight line. And like we did in our POD, my slope will be 1 and my intercept is negative 3. So I'm going to start at negative 3 on the y-axis, and then I'm going to go up 1 and over 1. Oh, and right there, the parabola and the line crossed. And if I go down 1 and back 1, then right there, they're going to cross again. So I already know I'm going to have 2 solutions to this system then. So I will have 1 solution here and 1 solution there. So then I need to find those ordered pairs and write them down. So the ordered pairs where they cross, let's see, that would be negative 3, negative 6. And then the other one is 2, negative 1. So for this system of equations, we get 2 equations, or I'm sorry, 2 ordered pairs. Okay, and that's because the parabola and the line crossed twice. So if I took either of these ordered pairs and substituted them into the parabola equation and the line equation, they would give me a true statement for both. Okay, so that's basically what we're going to do. We're just going to practice it a few more times. Okay, now in example 2, it says again to graph the system. And the first equation, that is my parabola because it has the x squared. And my second equation is going to be the line, but that equation's not solved for y. So I'm going to have to solve this equation for y. I'm going to have to subtract the x over to the other side. So then I'll have y equals negative x plus 1. Now, I like to graph the parabola first before I graph the line. That's just personal preference. Okay? It doesn't really matter which order you go in. But for my parabola now, remember I have a 1 x squared, and then a 2x and a minus 3. So that's a and b and c. And I need to do my negative b over 2a equation so that I can find the axis of symmetry in the middle of my table. So negative 2 over 2, that's going to be negative 1. And then I'll make my table of values. And again, it's good to have more values than what you think you might need. So let's even do 4 on either side. All right, now I have to substitute each of these values in. So if I did the 3, I would have 3 squared, which is 9. And then 2 times 3 is 6. So 9 plus 6 is going to be 15 minus 3. That will be 12. Okay, so I need to take each one of these x values, substitute it into this equation, and these are the y values that I should get out. So negative 3, negative 4. And remember, the negative 1 was my x value in my vertex. So now the pattern should repeat here. I should get a negative 3, 0, 5, 12. So actually, I wouldn't have to do those substitutions. I would just have to do 5 quick substitutions, and then I could rewrite my other answers once I knew that the pattern was developing. Now, negative 5, 12 won't fit on this graph. It'll go off the graph a little bit, but that's okay. It gives me direction. And then negative 4, 5, and then negative 3, 0, and negative 2, negative 3, negative 1, negative 4, and then 0, negative 3, 1, 0, 2, 5, and then my 3, 12 would be way off the graph. Let's make that a little bit better. There we go. Okay, so when we connect our points, we're going to make this nice U shape. And then my line right here, I'll do that in, oh, I guess let me do that in blue since we were using blue before. So I'm going to start at 1 for my intercept and then go down 1 and to the right 1. Oh, and right away, I get a spot where they cross. So then I can backtrack and see, looks like I'm going to hit this other point. Here we go. So again, I'm going to get 2 points where the parabola and the line cross. So now that I know those 2 points, all I have to do is read them off the graph. So the point on the left, that would be 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's negative 4, 5. And then the other point is going to be 1, 0. So those are my 2 solutions. And again, if I took those ordered pairs and put them into the original equations, both of them would give me a true statement for both equations. So that's a good way that you can double check your work. Okay, let's do one last one, and then I'll show you how you can do this on your graphing calculator as well. Right, now example 3 is slightly different just because they don't give us a line with any slope. They give us this special type of line, y equals 4. So that is going to be my line. The x squared minus y equals 0. That's going to be my parabola. Again, I know that because it has the squared. Now this line, this is just y equals 4. So remember, when it's y equals a number or x equals a number, that's either a horizontal or a vertical line. Remember the little poem, why am I laid out when I slip and fall? So this y equals 4, that's going to be the horizontal line. It's going to be laid out from left to right at 4. So since it's a horizontal line, we can just go ahead and graph that first. I know I said I usually like to do the parabola first, but it doesn't really matter. Now the other equation then is going to be my parabola, but I have to solve it for y. So there's a couple different ways you could do this. You could subtract the x squared over and then divide everything by -1, or you could just add the y over to the other side. Whoa, what happened there? Okay, so then you get x squared equals y, and if you want to flip-flop it around, you can. Y equals x squared. So really what this is then is y equals 1x squared plus 0x plus 0. Okay, so my a term is 1, b term is 0, c term is 0. If I do my negative b over 2a, that would be 0 over 2, which is just 0. So that's where I'm going to start my table of values. And I'm going to pick a couple values above it, and a couple values below it, or to the left and to the right. And again, I'm going to substitute these into my equation. Now my equation was x squared equals y. So basically I just have to square all of these. So 9, 4, 1, 0, 1, 4, 9. And then I'm going to graph. So -3, 9, -2, 4. Oh, look at that. -1, 1, 0, 0. So then over here, 2, 4, 3, 9. So even if I don't graph the parabola first, if I graph my line first and then the parabola, I can still clearly see where they cross. So the point on the left is going to be -2, 4, and the point on the right is going to be 2, 4. So those would be my two solutions for this system of equations. Okay, so you might get some horizontal lines. You might also get a vertical line. If you had a vertical line, let's ask that. What if we had a vertical line and a parabola? Okay, so if we just do a rough little sketch of that, here's my parabola, let's say. And then remember, a vertical line goes up and down. So when that happens, you're only going to get one solution. And you could have a case where the parabola and the line never touch. The line might be going horizontal, but it might be way underneath the parabola, so it never touches it. So if that happens, you would have no solution. I don't think you're going to see any of that, but be aware of it, that if they don't cross, there's no solution. And you should be familiar with that concept from doing our systems of linear equations. Okay, now the only other thing in notes is how you can do this on your graphing calculator. So I'll go to the graphing calculator and I'll just type in, let's see, let's just do example 1 since it was already solved for y. If it wasn't solved for y, you would want to solve the equations for y. And then you want to go to y equals and you want to type the equations in. So we had -x squared plus 3 and hit enter and it'll go to the next line. Then we had y equals x minus 3. Okay, so you type in both equations. You can graph if you would like to graph and see what it looks like. But it's really hard to read off of the graph just by looking at it. So we're going to find the intersection. So you want to do second and then the trace button. And then we want to do option number 5, which is the intersection. Okay, now we have to use our arrow keys, so we have to arrow over. So we're a little bit closer to our first solution. And then we're going to hit enter and say, yeah, that's the first curve. Now, the first curve, when the calculator says that, it really means, is this your first equation? So you can just hit enter and say yes. And then notice that the cursor automatically moves to the next line. And it says second curve. So then just hit enter to tell the calculator yes. And then the calculator is going to say guess. That's the calculator's way of saying, are you sure you want me to do this? So we'll hit enter again, and it's going to tell me the intersection. -3, -6, right there at the bottom of the screen. Okay, -3, -6. So that got me the intersection on the left. If you clear it, you can do it again and find the intersection on the right. So again, do second trace, 5, and now we're going to arrow over to the right side of the parabola. So we get close to that intersection. Hit enter. The calculator automatically moves the cursor to the line. So hit enter and say, yeah, that's my second curve. Hit enter again to say, yeah, I want you to find the solution. And there it is, 2, -1. Okay, so if you have a graphing calculator, this could be a way to double check your work, not do the work. We want to see the table of values. We want to see the substitution if you're substituting the work in for making the table of values. So don't rely on the graphing calculator to do this for you, but you can use it to check your answers. Okay. So your homework tonight is, like I said, the system of equations worksheet, and you can either pick that up in class or you can print it off the class website. So make your table of values, make sure each equation is solved for y, graph them, and find where they cross. You should get 2 or 1 solution. I don't think there's any where there's no solution. But if you have questions, come on in and see us before school.